Last section here. We're going to start actually talking more about, in writing, some geometric proofs. Okay? You've done some algebraic proofs where we're pretty much just using those properties: addition, subtraction, multiplication, division, distributive, substitution, those kinds of things. We're going to start adding in our geometric rules as well. Definition of a proof. Again, some vocabulary that you got to make sure you remember. Definition of a proof is a logical argument that shows a statement is true. Okay? A logical argument. Could also insert the word sequential. A logical, sequential argument that shows a statement is true. A lot of different types of proofs. We're going to take a look at two-column proofs. We're also going to take a look at flowchart proofs. We'll also take a look at coordinate proofs, I believe. But then there's also paragraph proofs where you're just writing, almost like an essay. Right? There are proofs by contradiction. There are inductive proofs. There are a lot of other different types of proofs. But we're going to focus right now on two-column proofs, and cleverly called two-column proofs because they involve the use of two columns. Okay? Your two columns, your left-hand side is reserved for your statements. This is what we know. Okay? And each statement that you write down needs to come from information before it. Whether it was another statement in your proof, or sometimes we get to use the diagram. Your right-hand column is reserved for your reason for writing down that statement. If you can't think of a reason for writing down that statement, then you probably should not be writing down that statement. Okay? Now, the reasons that we get to use are all definitions, postulates, theorems, or properties. We ought to add in there properties that we've talked about along the way. Okay? And so a number of statements and corresponding reasons that show an argument in logical and sequential order. Okay? There are going to be times where I tell you that, oh, you had to say this statement before this other one. You're going to get all salty and mad at me, and that's okay. Okay? But we have to make sure that it's sequential and that each step comes from a statement before it. Okay? And then we talked about theorems a little bit before. Postulates are rules that do not need to be proven. Theorems do. Theorem is a statement that can be proven. Not can be, but should be and needs to be before we can accept them as being true. Okay? All right? And that's about as much information as you get from two-column proofs. I've said it before. I'll say it again. I'll probably say it several more times before we're done here. You have to start writing your statements in your proofs yourself. Okay? We'll talk more about that in just a second. But asking for help is good. But getting over this fear of coming up with statements is you're not going to be able to do that until you just start writing statements, get them wrong, write a statement down wrong, find out why, and learn. Okay? But we'll talk some more about that in just a second. All right. So, write a two-column proof for the situation example 4 from lesson 2.5. I'm not exactly sure what that means, other than it might refer back to one of your examples earlier in your notes. I don't really care. I'm going to write a two-column proof for this situation going on right here. Okay? So, we're told that the measure of angle 1 equals the measure of angle 3. And we want to prove that the measure of angle EBA equals the measure of angle DBC. Now, this is how this works. Okay? Always, 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 we have to have a starting point. Okay? Well, we're doing a two-column proof, so we need to have our two columns, statements and reasons. And we have to have a starting point. The starting point is always going to be some given information. Just like our algebraic proofs, we started with the equation. The equation was given to us. So we write in our given information. The measure of angle 1 equals the measure of angle 3. How do we know that? Because someone told us that it was given to us. Okay? This is where you're going to freeze. Some of you. And this is what I mean. This is the point right now, the second statement. This is the one that you have to just try something. Write something down that you know is true, either from the diagram or from the previous statements, and that has a good reason, and see if it helps you get to where you want to go. Now you do have to remember where you want to go. Right? And this is where we want to go. We want to say the measure of angle EBA equals the measure of angle DBC. Alright, so here's what's going to happen. I need to find a statement that I can write. Preferably that deals with angles, since what was given to me is angles, and what I want to prove are all about angles. So, I look. I don't know, there's not much to write from that first statement. So look in the diagram. If you look in the diagram, one of the things that we could write is that since we want to prove something about the measure of angle EBA, why don't we talk about it? The measure of angle EBA has to be equal to the measure of angle 3 plus the measure of angle 2. EBA is right here. And so from the angle addition postulate, we do know that the measure of angle EBA has to be equal to these two guys added together. Okay? Now, angle addition postulate allows me to write that statement. I have no idea if that's going to help me get to where I want to go or not. I don't know. Hopefully we can write a few more statements and we'll find out pretty quickly if this is where I want to, if this is going to take me where I want to go or not. It talks about one of the angles that I want to prove, so it can't be that far off. Okay? Now what? Well, if it worked for EBA, can we do it for DBC also? And the answer is yeah. Okay? But I forgot, we'll do that in a second. Okay? So we'll talk about DBC in a second, but what we can do at this point is leave the diagram and we can combine these two statements, and that's okay. We know that the measure of angle EBA equals 3 plus 2. We know that 1 and 3 are the same. So I can actually replace the measure of angle 3 with the measure of angle 1. And that's just by substituting. That's the substitution property. Okay? Again, not knowing if that's going to take me where I want to go, but I know that that's true, so we can write it in there and go from there. Okay. Now this is what I was going to get at in a second ago, right? Is if you look at angle DBC, we can use the angle addition postulate for that guy also. Angle DBC has to be equal to angle 1 and angle 2 added together, and that's from the angle addition postulate again. Okay. In an effort to explain my trip up a second ago, it's entirely possible that you could have written this guy here before step 3. You could have done that and been okay. All right? That's where I would have maybe have gone, but that's okay. All right? Anyway, so we've got the measure of angle DBC equals angle 1 plus angle 2. So does angle EBA from that third statement, right? So, since they're both equal to the same thing, we can say that they're equal to each other. The measure of angle EBA equals the measure of angle DBC. Why? Well, you've got this to this and this to this. So we could use the transitive property, right? That's that sort of pseudo law of syllogism thing. Transitive property. And that's what we wanted to prove. That's what we wanted to show. And so we're done. Once we write down as a statement what we wanted to prove, we're done. Okay? Does that make sense? Okay. Ignore this for a second. You've got a couple of proofs in there. Okay, so we start with the given information. M is the midpoint of segment AB. Okay. A couple of different ways you can approach this. One is you could go back into your diagram and actually use the segment addition postulate, because we keep doing that, right? And that's what I mean by proof writing sometimes just being by experience. Since you've seen that strategy before, you could do that again here. Okay? Or you could go to your first statement and use what you know about midpoints. Since M is the midpoint of segment AB, that means that segment AM and segment MB have to be congruent. We just use the definition of midpoint to get there. Now, from here, we need to jump down, and instead of talking about the actual segments being congruent, talk about their measures being equal. And the reason why we need to do that is because everything that you're trying to prove is all about measures and not the actual segments. So we do that here to get us back into the mode of talking about the segment lengths and not the actual segments themselves. So since the segments are congruent, we say the lengths of the segments are the same, and that's by definition of congruent segments. That's back in your Chapter 1 notes. Now we can bring down the segment addition postulate from your diagram, right? We know that this has to be true because of this. And since we're using the segment addition postulate, we need to put that in. And again, this is a postulate, so I'm going to add postulate here. Okay. Now, from here, we see that AM is equal to MB. And then we have MB down here. So we can substitute AM in for MB. And when we do that, we get AM plus AM equals AB. Okay, and we do that by substitution. Now, simply combine like terms here. AM plus AM is 2AM. Okay. And this is called the substitution property, because basically you're substituting 2AM in for AM plus AM. And as a geometric property, that's what you need to use, is the substitution property. It's a little weird, where in the algebraic world, we were just simplifying or combining like terms. Okay. Here in geometry, we use the substitution property to substitute 2AM in for AM plus AM. Okay, just keep that in mind going forward. Now, because we have 2AM equals AB, and that's one of the things that we wanted to prove, we also wanted to prove that AM is 1/2 AB. Well, we can get that pretty quickly just by dividing both sides by 2. And so using the division property. Okay, and that's what that proof would look like. There are more proofs out in Canvas. We'll probably bring those up and use those as warm-ups over the next couple of class periods. But we need to get good at writing these proofs. So make sure you get your homework done. It's out in Canvas for you, and we'll see you next time.